we all know that the liquids will flow. So that flow is to be measured. How to measure that flow? We are having the various devices for that. So here we are having the orifice meters. So this one is the orifice meter, this is the venturometer, and the nozzle is there. So these these devices we are using to measure the flow through pipes. Now our question is to find the discharge, also measurement of flow of a river. So measurement of flow through the channel, that is our question now. How to measure that? For that we are having a notches here. So these are the notches which are used to measure the flow through the channels. For flow measurements we are using these notches. And wears are also there. Wears are used to measure the large flows. Okay, here in our experiment, here we will conduct experiment on the notches. So here we will measure the flow through these notches. So we will measure the discharge here. So this is there are various types of notches. This is the rectangular notch, the rectangular shape you can see here, and this is a V-shaped notch. Okay, this one, and two V-shaped notches we are having. This one is a 60 degree, the angle is 60 degree here, and here one more notch is there, that is a 90 degree, the angle is 90 degree. First, let me explain regarding the parts of this experiment setup. So this is the pointer gauge here, and this is the pump here, and this is the valve. We can adjust the flow rate by using this valve, and this is the piezometer, and this is the collecting tank. So water will fall into this collecting tank, and we can measure the rise of water by referring this piezometer, and this is the water tank arrays. See, this is the V notch. This point, whatever the sharp edge is there, sharp point is there, this one is known as a crest. The amount of water that is flowing over this, some amount of water that is flowing over this crest, that is the nepe, we will call it as. So now we can now we will go through the observation and tabulation and calculation. So later we can conduct the experiment here. Aim is to measure the discharge of the liquid. That is, and next one is the second aim is to determine the coefficient of discharge. So we will go through the observation. Observation, that is the first one. We will get the theta, that is the angle. That is whatever just triangle or not we are observed. This angle is the theta. Okay, sorry, it's this angle is the theta. This one 60 degree, but actually we can use the one more V naught we are having. That angle is theta is 90 degree. Two types of V naughts are there. Okay. Now whatever I have just used, that is 90 degree V naught, that is, and the area of that collecting tank, that area is 0.0768 meter square. So next one is the tabulation. Tabulation consists of serial number, valve position. There are three valve positions we can get the readings, and H1, H2. These things I will show you when I am conducting the experiment. And time taken for 10 cc correction of water. Okay, this tabulation I will show you when I am taking the readings. That time I will explain what are these things. Okay, next is calculation. The first one is calculation, that is the actual discharge you need to find out. That is area A, this is the area A, that is the area of collecting tank, and R is the rise of water for 10 cc of water. This is R, and 100 is the conversion factor. T is the time collected, amount of time collected for that time. So okay, next one is the theoretical discharge. So this actually I didn't derive here, I used the formula directly. Okay, 8 by 15 tan theta by 2 square root of 2g h 5 by 2. So g is the gravity. Okay, h is that is the head. This h, that is the head, and theta is the angle here, 90 degree. Okay. And now later we will find the coefficient of discharge. That is aim of that. Okay. Coefficient discharge is equal to coefficient actual discharge divided by the theoretical discharge. After this calculation, you can plot the graph, that is Q actual versus H head. Okay, you need to plot this graph, that is Q actual versus head. That one you need to plot that graph. So this is the V naught here. The angle is theta. Okay, I will draw that. So the amount of water that is in the V naught from here up to the crest, this height is h. That h we find out here. And this small strip, if I am considering, this is dh. Okay, that is dh. So amount of water that is coming out of this V naught here, amount of water that is coming out of this V naught, that is called as net by. Okay, now we will go through the procedure to conduct the experiment. First you have to start the button. This is the start button, and you need to check the, before that you need to check the valve whether it is opened or not. So valve should be completely opened. Okay, so then you need to switch on this button. So you need to allow the free flow of water. So water will flow, the water will flow, and you need to stop, you need to switch off the button after when the water comes out of this crest. So when the water comes out of this crest, you need to switch off the button. So you need to allow to settle down the water completely. Once the water is settled down up to this crest level, then you need to measure the height of that water using this pointer gauge here. By touching like this to the surface of this water, you need to measure the height, that is h1, small h1. Okay, like this you need to measure, that is small h1. You just touch the surface of water. Once the water is settled down, that means once the water is stopped the flowing out of this crest, then you need to measure here using the pointer gauge, and this pointer gauge should touch the surface of this water level, and then you measure the scale here, that is h1, small h1. Once it has been settled down, water completely settled down, now you can switch on the button. Okay, now you can switch on the button. So whatever the amount of flow of water, free flow of water, okay, it will take place. You need to wait for some time. Okay, later you take the, once again you set this pointer gauge for that level of water, and you can take the reading, that is h2. Okay, and afterwards, once this h1 and h2 is taken the readings, then you need to find out find out the time for collection of amount of water in the collecting tank. Okay.
Sure, sir.
And now I will find the h1 first by touching the pointer gauge to the surface of the water here, because now water flow out of this crest has been stopped. Now I will find out the h1 first by touching this pointer gauge to the water surface. Okay. Once I got, this is almost 5.7. The reading is h1, small h1 is 5.7. It is there, that reading. Okay. Once I got this small h1, now I will switch on this button so that I will allow the flow of water through the notch. Coming out of this knot, this one is called as neppe. Okay, this is neppe, whatever I told you. And this point is start by this point is known as, this is the crest. So neppe that is coming out of this knot, the amount of water that is coming out. Now I will adjust this water gauge to the surface. Now the reading is 11.2. Now the reading is 11.2. Now the reading is 11.2. This is a small h2. This is small h2. H1 already I have taken. This is 11.2 is there. So once I noted this S2, now I will go through this time to collect the amount of water in the tank. This is the collecting tank. So I will throw this wall. So I will throw this wall. The amount of water that is rising in the collecting tank here. Again, for 10 cc of collection of water, I will note the readings. I will throw this wall. The amount of water is rising here. Now I will go to the readings. So I have basically, so almost 7 seconds, the time is 7 seconds. Okay, the time of collection of this water in the collecting tank, that is 7 seconds. Now I got this reading, all the readings here. This is the H1, H2 and this the time for collection of amount of water, all the readings I got. Now I will turn this wall for the second set of reading. I will adjust the flow rate. I will go almost now once again I will wait for 1 minute for the flow settlement because I have adjusted the wall. I will wait for 1 minute to settle the flow. Once the uniform flow is taken, once the uniform flow is happened, then I will set the once again this pointer gauge to measure the F2. So now almost 30 seconds work. So now the flow is uniform. The flow is uniform now. So that I will adjust this pointer gauge once again. Okay, I have adjusted the pointer gauge. Now the reading is 10.8. Okay, now the reading is 10.8. Earlier it was 11.3. Okay, 10.3. So this is how I will take the second set of reading. That is the H2 I will take. And once again I need to measure the time collection of amount of water. Once again, I call this. Yes. It's almost 8 seconds. Okay, it's almost 8 seconds. Earlier it was the 7 seconds. So this is how we will conduct the experiment, and later we will use this data and the tabular column. We can write all those things and we will calculate we will do the calculations. Now this H1 whatever we are measured, that is up to the crest level when the water is settled on, when the uniform flow is there. Okay, afterwards the water is settled on up to the crest level. The H1 I measured, that is 6 centimeter, that is almost 6 centimeter. I am writing approximate values here, not the exact value. H1 is 6 centimeter. So for the fully open position, this is the wall position is fully open. That is first one. That is wall position is fully open. And the S2 I have measured, that is 11.2 centimeter. That is S2 11.2 centimeter. So H1 minus H2 you will get almost 5.8 centimeters. Okay. H1 minus H2 you will get almost 11.2 minus 6, 5.2 centimeters you will get. Almost H. Okay. So H is equal to value in terms of meters you will get. Time of collection of water, that is first one is 7, approximate values I am writing, 7 seconds. 7 seconds. So once you got this readings, 6 centimeter, 11.2 centimeter, H also will get, and 7 seconds also will get. We can find out the actual discharge. This R is the 10. This is okay, because 10 cc rise of amount of water, that one we are collected. So that R you need to substitute here R10, and then you need to substitute here area of that collecting tank, and then this is the time 7 seconds. Like this we will calculate and we will find the discharge, cost of discharge to actual divided by theoretical, and then we can plot the graph for the various openings. Okay, openings we will get all these values, then we can find out we can draw the graph of that. The nature of graph will be like this. It will be like this nature of graph. Q actual divided by H. Q actual divided by H. The nature of graph will be like this. Okay, you can go through the calculations, you can find out the things. Thank you and all.